Hi, so we'll talk about a couple more examples on MapReduce, and they'll lead us to the idea of functional programming. So here is an exercise for you. Actually, we just want to rewrite an example that we saw at the beginning of this video that we want to sum up the square of all the elements in a given list. Now, this time using map and reduce and potentially in one line if you can manage. So please give that a try. All right, so here is how I am going to write it. So remember, to sum things up, we are going to have to do lambda a b, right? A plus b. And now the iterable or the list is going to be a new list with all these elements from the original list squared. So this is, I'm going to write a map that square each of the elements. So each of the element would be x, so square them, and I'm going to apply this function to the original list. So that's that, and hopefully let's check. Yes, it gets 95, and you can verify 95 is the sum of each of these numbers squared. And here is a second exercise. So given a list or an iterable and a key, in this case it's just a number, so please write a single statement that use both map and reduce, and it should return true if the key is in the list and false otherwise. So this might be a little different from what you've seen so far. So think about, given this list of numbers, what can you do to map each of these values to another value that would help you to determine ultimately, when you put everything together, if the key is in the list. So please give this a try. All right, so this is how I would approach this problem. So first, given a single key and all these elements, then what I would like to know is if the key is equal to each of these elements. So the function that I'll map to these elements would be a equality check, and the output from there would be a Boolean of true or false, right? So I'll check if 2 is equal to the element 2. Is 2 equal to the element 1? Is 2 the key equal to the element 9? And etc. Right? Then I get a bunch of true and falses. In this case, this 2, the key is equal to the first element, so I get a true, and then false for the rest of the elements here. Now, with a new list of true or false that tells me whether the key is equal to each of the elements, then in the reduce function, what then I would do is to figure out if at least one of these elements is true, right? If one or more of them is true, then I know at least one or more of the elements is equal to the key. So the operation that I'll use for reduce will be the OR, and that's how it will at the end tell me if the key is in the given list. And the way that I'll write this is that I'll first do the mapping, right? So I'll map the function that I want to map is x is each of the elements equal to the key, right? And I'll apply that function to the input list, the iterable. And now I have this new list, and I'm going to do a reduce on them, right? So I'm going to reduce, and the like I said, I'm going to do an OR between each pair of elements in the new or the intermediate list. So a OR B, and I'm going to apply that to this new transformed list. Now, one final thing is always think about what we should return in the case that the input list or iterable is empty. Well, if it's empty, then for sure the key is not in that list, right? So the default value or the initial value for an empty list, then it will be false. So let's check if 2 is in the iterable, it should be true. Yeah, where did it go? Okay, so it is true. And let's say we change it to something like a 10, which is not in the list, and it returns false. And that's what this slide is trying to explain, and hopefully that makes sense. Now, the next thing I want to discuss is now that we've written a few statements using MapReduce, and we also obviously knew how to write those before using just for loops and iterations and all that. So, and I put them in kind of side-by-side columns, and so take a look at them, and I want you to think maybe a little deeply about what their differences are, right? I mean, aside from the obvious, I mean, this is using MapReduce, and this is using lambda, and these are not, right? So aside from the obvious, what are different between these two? So there are two main things that I want to point out. So the first is using MapReduce and higher order functions and lambdas and all that. It does not have these things called state variables. Now, obviously, they do use variables, but what I mean by state variable is, for example, in the code to look for the smallest value in the list, we initialize the smallest to something, and then we iterate over the list and we update the smallest value if we need to, right? So this smallest, the number keeps changing. So that's keeping a state for each iteration in the loop. So that's something that we have to manage. Same thing for the sum, right? We have to initialize the sum for something to some value, and then we have to, for each iteration in the loop, we have to do something with the sum. We have to update the sum, right? Now, state variables, I don't know what your experiences are, maybe not in something as simple as this, but they can actually cause troubles and introduce bugs, especially if your loop is a little bigger, something more than a couple lines, and you may have more than one state variable in the loop. So you have to, basically remember to initialize them to something, and then make sure you update it correctly in the current iteration and in preparation for the next iteration, etc. Right? So there are actually a lot of things that you have to do right about these state variables to make your program work the way that you want to. And that's only that, and we're only talking about local variables here. So when we talk about things like instance attributes or even class attributes or global variables, those things, they live a lot longer than just a local variable that we use in here. And those, you really have to care about who sets them to what. Otherwise, you probably have had bugs before when you set certain variable or certain attributes to something that you didn't intend to. So state variable like these, they are actually, because they do tend to introduce bugs and all that, they are considered undesirable by this thing called a functional programming paradigm, if you heard of it before. Now, before I get there, the other thing that I want to point out is that when we look at the statements using reduce and map and lambdas, so it's very obvious, or at least it's quite readable, what we want to do in this, say, reduce thing, right? We are looking for the smaller of the two, right? And here it's also obvious that we are adding the numbers together, right? Now compare that to this. Again, because of the state variable, then we have to think about, oh, so what are we trying to what does the smallest stand for? Well, okay, so if something is smaller than the smallest, then that something becomes the smallest. Okay, so I guess we are looking for the smaller of the two numbers, right? So there's a little kind of a cognitive exercise before we can we can really try to really understand what this loop is doing. But here again, it's very obvious we are just looking for the smaller of the two. And when we do that pairwise for everything, then we're looking for the smallest in the element. So in some sense, especially if once you're used to this idea of thinking and programming, then it's quite obvious, or it's a lot more readable, what your statement, what your code is trying to do. So those lead me to introduce you to the idea of functional programming. If you haven't heard of it before, some of you might have. So functional programming is one of the programming paradigms, like a way of thinking about programming, just like procedural programming or object-oriented programming. So functional programming is one of the programming paradigms, and some of the ideas that they use is what we've been studying, higher order functions and recursion, and then the idea of not using any state variables. Use a few other ideas, but these are the main ones. Now, functional programming, it's been really kind of around for a long time, probably since the very early days of computer science, and in recent years or decades, it's coming back and becoming very popular. I mean, thanks to the idea of MapReduce, and also I really just think because it is very, very elegant because, again, many of the things that we study, like higher order functions, lambdas, and things like that, they're really kind of based on math or mathematical concepts. And when you talk about math, it's really a lot of very, very elegant ideas. So anyway, Python, as we saw, it supports functional programming, and obviously it supports the procedural programming that we studied before, as well as object-oriented programming. So it's good. We can do pretty much program things any way we want using Python. And this is a cartoon that I always like to show when I talk about functional programming. And most of you probably didn't have to program in machine language or assembly language, but you definitely have done procedural programming, and you're studying object-oriented programming, and now you're hopefully kind of well versed in functional programming. Now, I don't necessarily think that functional programming is more evolved than the other two paradigms, but you know, they're just different ways of thinking about problems, and they all have their places in programming, and then they can all be used together. They're not mutually exclusive. So it's great that we have all these tools in our tool set.